Elimination Method. Now remember, Monday you have a quiz. It will cover everything that we've done from last week, the end of last trimester, and this week, the beginning of this trimester. So if you have all of those assignments, that would be something really good for you to bring together, to look through, to look at corrections that Mr. G has made, and figure out what you're going to use to study. I would take notes and put them inside your notebook. If I had you write something down, it was probably important. So I would include that in your notebook or create a note card. I would prefer you guys create a note card. Let's get used to using that note card. For some of you, it's something that is allowed on every class. For math, I think it's a really good strategy to help you study. So come up with a note card and let's get this done. All right, so let's go ahead and look at this. Number 1. Jacob and Stephanie are selling pies for a school fundraiser. So we're talking about pies now. Customers can buy a cherry pie and a pumpkin pie. Okay, so let's say C for cherry and P for pumpkin. Jacob sold 8 cherry pies, so let's say 8 cherry and 2 pumpkins for a total of $66. Right? What did Stephanie do? She sold 10 cherry pies and 9 pumpkin for a total of $141. Okay, look at these numbers carefully. What can I do? Do I have to multiply 1? What are those 2 things that I'm looking for again to do elimination? Same digit, opposite sign. Do I have same digit, opposite sign here? They're same sign, different digits. So I need to multiply 1 by a negative, but I'm going to have to multiply both rows, aren't I? Because I can't multiply 2 by anything to make it 9, and I can't multiply 8 by anything to make it 10. But I can look for a least common multiple, right? So what is the least common multiple? I kind of want to look at this 8 and 10 because I know there's something that I could probably do here. Okay? So I'm going to write my multiples on the side here. I have 8, 16, 24, 32, and 40. I know 40 is going to be a multiple of 10, right? So I know that this 40 is probably going to be the one that works for me. That means it's 8 times what? 8 times 5 is going to give me 40, right? And 10 times what is going to give me 40? So those are smaller numbers than multiplying by 9, right? Because I think 9 and 2 would give us some bigger numbers. 2 wouldn't, but 9 would. Okay, so let's see if we can multiply this out. But which one do we want to make our negative? Our top one? Does it matter? Either way, it's going to work out. So let's try the top one. And remember, I don't do anything without my calculator. Why? Why should I? Okay, I can use a calculator. You can use a calculator. It's okay to use a calculator in this class. This is a battle I do not choose to fight. You guys are in the 8th grade. If you don't know your timetables, if you can't do this multiplication on your own, in your head, and those of you that do try to do it in your head usually make a mistake, use a calculator. Not a big deal. Okay? As long as you're showing me the process, that's what's important to me right now. I'm not checking to see that you know how to multiply. I'm checking to see that you know the process. That's what's important to me right now. So I'm going to take my calculator. I'm going to multiply this out. So I know that negative 5 times 8 is negative 40 just because I know that. I also know that negative 5 times 2 is going to be negative 10. Right? I got ahead of myself. Minus 10p. But 66 times 5, I don't know. So I'm going to say 66 times 5 is going to give me a negative 330. Negative times a positive. All right, so let's multiply the next row. 4 times 10 is what? 40C positive, right? 4 times 9 is what? 36P positive. And what's 4 times 141? I don't know. I'm going to multiply it. 564. Angel knew. He used a calculator though, right? No? All right, so let's go ahead and subtract it. So now all we're doing is we're adding. Okay? So one way to look at it is by saying, okay, I'm going to look at this. This is my addition problem. Old school, right? Negative 40 plus 40 is what? Yeah. So I'm going to cross it out. I'm going to look at my next one here. Negative 10p plus 36p is what? Positive 26p. Right? Now this one's a little trickier. I have negative 330 or 564. Really, another way of looking at that is just saying 564 minus 330. What does that give me? Positive 234. And now I can solve for p by doing what? I'm going to divide both sides by 26. I just so happen to have, oh no I don't, 234 divided by 26 gives me 9. Now again, what does p equal then? So pumpkin pie is $9. What is the question it's asking me though? And 1 pumpkin pie. So I know the pumpkin pie. Do I know how much the cherry pie costs yet? Can I figure that out though? I can substitute it into one of my equations. Which one do you think is probably the easier one to do? Top or bottom? Me too. So I'm going to say 8 cherry pies plus 2, and instead of p, we're going to say 9, right? 9 pumpkin pies is going to be equal to $66. And then I need to solve my problem. So the hardest part, what do you think the hardest part is on this problem? Finding out what you're going to multiply by, right? You're going to have to multiply both for these problems. We're going to do a couple together. So what is 2 times 9 then? So I can say 8c plus 18 is equal to 66. How do I move my 18? Subtract it from both sides, right? I now have 8c is equal to, I'm going to have to borrow here, 48. And then what? Divide both sides by 8. What does c equal? Equals $6. So remember, I'm looking to see my sentence answer. How do you answer a word problem? With words, right? So how would I answer this question? Ah. Which pie costs what? So you want to be specific with your answer, right? Not just the cost of each pie. Because it's asking me for the cost of 1 cherry pie and 1 pumpkin pie. So, Grant, how would you say that?
The cost of the cherry pie is $6 and the cost of the pumpkin pie is $9.
Perfect. Okay, so be specific with your answer. Make sense? Because each pie doesn't cost $9. One of them costs 9, one of them costs 6. Okay? They don't all cost 9 or 6. It's not random. It's very specific. So should your answer be. All right? Let's look at number 4. Aaliyah's school is selling tickets to a play. So we have a new event happening. It's not cakes and pies. On the first day of ticket sales, the school sold 8 senior citizen tickets and 7 children tickets. So we can say 8 senior, right? And how many children? How many children? How many children?
7.
Thank you. 7 C. And how much money did they make that day? $210. Here's my second equation now. The school took in $224 on the second day by selling how many senior?
10.
And how many child? So I'm going to put this information in there. 10 senior and 6 child. And they made how much money? 224. Same issue here, right? I have that same problem where I can't turn an 8 into 10, I can't turn a 6 into 7, and vice versa. So I need to find a common denominator. Do you think, since I have the same numbers here that I had up here, that those numbers might work down here as well? So doing this is important for 2 reasons. Not only did it help you solve this problem, but in the future, it already provides the foundation for maybe one that you're going to have to find again. Okay, so if I was me, and I am, I would just take the information that I had up here and transfer it down here. Multiply 1 by 5 and 1 by 4, and choose one to be negative. Okay, so I know that I'm going to do that again. I know that I'm going to multiply my top and my bottom. So I'm going to go ahead and bracket those. Which one do I want to multiply by 5 and which one do I want to multiply by 4? The top by 5 and the bottom by 4?
Bottom by 5, top by 4.
Does it matter? Mm-mm. Which one do I want to make negative? The top one? Okay. Let's do it. Take your calculators if you have one and multiply it out. 5 times 8. So, you have a question? What numbers did I have up here? Up here. And what did I use? And how did I find those? I looked for least common multiple. 8, 16, 24, 32, 40. This is 8 times 5, right? 10, 20, 30, 40. This is 10 times 4. 4 and 5. Do you understand? All right, so let's do our multiplication. Negative 5 times a positive 8 is going to be what? Negative 40. S. A negative 5 times a positive 7 is going to be what? Negative what? Negative 35 C. A negative 5 times a positive 210 is going to be what? $1,050. Right? And then I'm going to multiply this out. And remember, this is just distributive property. Multiplying 4 times 10s, 4 times 6c, and 4 times 24. Still using distributive property. So if you have that list that I gave you of the steps that you need to do to solve a multi-step equation, you just follow it. Okay? What's 4 times 10? So I have 40s. What's 4 times 6? 24. What is 4 times 224? Positive 896. Then I can just add them up, right? This becomes what? 0. So then I can look at this. I have a negative 35 and a positive 34. So this is really negative 11, right? Because my negative is bigger. So negative 11C. And then I have 1,050 and 896. So I want to find the difference, right? Because there's a positive and a negative. What's the difference? Negative 154. Okay, how do I solve this now? By 11, right? When I do that, okay, I want to make sure that I divide by a negative 11, okay, because I want this to be positive. So when I divide this by negative, they both become positive. When I divide negative 154 by negative 11, they both become positive. So what does C equal? 14. So the cost of a child ticket is $14. My question says find the price of a senior ticket and the price of a child ticket. So now I know the price of a child ticket, but I don't know the price of a senior ticket. Can I use that information and solve my problem? Which one do you want to use? Top or bottom? Top, okay. 8C, does it matter? Either one will work. Times 7 times, and it's not going to be C anymore because C equals 14. So 7 times 14, and it's going to equal 210. So what is 7 times 14? Do the math. What is 7 times 14? What did you say? 98. What do I do now? Add the opposite or subtract 98 from both sides, right? What does that give me? $112. What do I do now? Both sides by what number? What do you got? Oh, look at that. So my child ticket is $14 and the senior citizen ticket is $14. So it really doesn't pay to be young or old in this day. Okay, you guys really need some practice. So I'm going to call on you randomly and you're going to set up a problem for me. And we're just talking about setting the problem up. Okay, so go back to number 2. Saul, set up number 2 for me. Sure. All right, go.
Senior class high school, we rented and filled 9 vans and 6 buses with 294 students. So what I did, I put 9B plus 6B equals 294 students.
Lovely.
Next, what I did was high school B rented and filled 8 vans and 4 buses with 220 students. So what I did was I put 8B plus 4B equals 220.
Lovely. That's perfect. All right. Anthony, number 3. Read it and set it up for me. I'll give you time. Okay, Anthony. What do I do?
There are 6 gold tickets and 7 students. 6A plus 7S equals 118.
Great. What's my second equation?
10A plus 3S equals 162.
Perfect. Did everybody have that same thing as well? Good. We're going to do one more. Ryuki, number 5. Look at that. He's ready. Hold on. I'm not ready. 4v plus 5v. How many? Look at it again. Okay. Perfect. So you guys can set these up super easy now, right? So setting it up's the easy part, right? So now we're going to work on, all of these are set up. Lovely. 2 of them are done. 3 you need to complete. We're going to look at this first page again. We're going to go back up to number 2. I want you to look at these numbers. Yes. I want you to look at these numbers really quick. Look at your V's and look at the numbers for your B's. Tell me which ones you think would be easier to eliminate. All right, so did you look at them? Which ones do you think would be easier to eliminate? Just by looking at them. 9 and 8 or 6 and 4? My B's or my V's? Okay. Which ones? Which one? V as in Victor? 9 and 8. Do you think they're going to have a smaller common denominator down lower? What about B? Do you think they might have a common denominator? Let's look, okay? I'm going to do 4 and then 8, right? And then 12. 6 is going to be 6 and 12. So would that be easier? 6 times what? 2 and 4 times what? So those are much smaller numbers. Saul, did you see how I got those smaller numbers?
Yeah.
Okay, what to look for. If you have your multiplication chart open, you can look at their products, the members of their fact family. In fact, hold on a sec. Right, so here's 8 and 9. Look, do they have a common denominator anywhere? I'm looking, I don't see one that's the same until I get to here. 72. Right? So 72 is going to be 9 times 8, and 72 is going to be 8 times 9. So multiplying them by each other. But if I look at 6 and 4, I have 4, 6, 12. Look at that, I have 12 here. So it makes it easier, right? So if you're using your multiplication chart to find your least common multiple, this is going to be easier for you. I also like just writing them on the side. Okay, so I can compare them right there. I don't like to go too high, like I'm not going to write 20 of them. I'm going to write maybe the first 6 and see if they have a common multiple. Kristen, you with me? Okay, so I've decided then that I'm going to multiply 1 by 6 and 1 by 2, right? So I need to multiply this by 2 to make it 12, right? 6 times 2. And I need to multiply my 4 times 3. But one of them has to be negative. Pick one. Top one. Okay? So now I've decided, together we've decided, that we're going to use these common multiples. We're going to do that again. Let's look at number 3. So now for number 2, you're ready to go. You know what you're multiplying it by. You just have to multiply it out and solve your problem. Set it up for you beautifully. Let's look at number 3. I have 6 and 10 and 7 and 3. Which ones do you think are going to be easier? Which ones? 6 and 10. Why do you say 6 and 10? Because 30 is smaller than 6 times 10, right? Which is 60. For 7 and 3, it's going to be some higher number. So let's see. 6 times what is going to be 30? 5. And 10 times what is going to be 30? So now I figured out my 2 numbers. Which one do you want to make negative? Okay, it's your choice. Either way, your answer is going to be the same. Does it have to be 5? Can I have said 3? Absolutely. Okay, absolutely. It could be either or. It's whatever works for you, whatever you feel comfortable doing. There's more than one way to cook an egg. Okay? And there's more than one way to solve this problem. Could I have multiplied the top by 10 and the bottom by 6 and still got the same answers? Absolutely. I'm still going to eliminate my A. Okay, so it's whatever you guys are comfortable with. For me, I like finding my least common multiplier. I like saying 6, 12, 18, 24, 30, 10, 20, 30. I like saying that. I like finding that. Okay, that's easy for me. That's the way I like to do it. All right, who wants to try and figure out the least common multiple for number 5? Noah, did I see your hand go up? Cool. Let's figure it out. 6 and 4 or 5 and 7? Which one's going to be easier to eliminate? All right, so let's do it, okay? So we have 4 and then what? 8. Oh, wow, 12 is a multiple of 6, isn't it? It goes 6, then 12. So could that work? So what am I going to multiply 4 by to make it 12? And what am I going to multiply 6 by to make it 12? Which one do you want to make negative? The bottom. Easy peasy. Okay. I have just set up successfully, or we have together, these 3. Okay. Now all you need to do is use distributive property, multiply it out, and solve the problem. I've done the hard part here. We've all established this together. Okay. So finish these 3 in the front, and then you have 5 for homework. Have a nice day.